Okay, happy Friday, everyone. Today is November 10th, and this is episode 33 of Get Your Tech On, our show on all things DOCSIS. I'm Brady Volpe, founder of the Volpe firm and Nimble This. With us today is John Downey, the man with all the muscles and the crystal ball gazer in cable. John is also CMTS Technical Leader at Cisco Systems. John, welcome back.
Oh, it's always great to be back. The pragmatic or protagonist or
prognosticator or something like that.
One of those.
So with us also is a special guest, Hugh Price-Stevens of Mariner XView, Director of Strategic Product Management, who is a typical Welshman, as he self-describes himself, and he brings your equipment to your door with a song and a dance on his way back from the pub with some rugby in between. He has a long history in the telecommunications dating back to the mid-1990s. Hugh, thanks so much for joining us today.
Thanks, Brady. Glad to be here.
So, Hugh, you've provided us some pictures, which maybe I hope to show, of the Valley. I'd like, maybe you can tell us a little bit, because I think everyone knows where John and I are broadcasting from, but if you can tell us, you're not from the United States. You're a little bit further away from us. So where are you exactly?
So I'm in Wales, which is a beautiful country, part of the United Kingdom. I live a couple of hours west of London, and as you said there, I live in an area called the Wye Valley. So it's a particularly beautiful part of the country. So I have to, whenever I'm exposed to the rest of the world, I have to do my bit for the local tourism industry. So that's our castle that Brady is showing a photograph of there, and you'll notice that there's a guy diving off the top of the ramparts there. That's when Red Bull cliff diving came to Wales. The guy did an illegal dive off the top of the castle about 100 feet into the river, just to show off a bit and promote Red Bull. But yeah, we've got the oldest surviving stone castle in the UK, and I live in this area where it was sort of the origins of tourism, because back in the late 1700s, the Romantic movement, the poets and the artists would travel around looking for inspiration, and the valley where I live was one of the first places they came to. This sort of very pretty river valley. It's not dramatic high mountains, but these rolling hills, a little bit like Middle Earth.
Absolutely beautiful.
Yeah, so that's just sort of a view of the valley about 5 miles from where I live here. And this one is actually even closer. This is just a couple of miles, a couple of bends up the river from the castle. So this is just, in the neighborhood. So I shared these photos with Brady just to say, if there's someone coming from a bit further afield, probably interesting to get the context. And that's the castle just down the road from the house. So that's about half a mile down the hill from my house, very close to the pub. The pub actually backs out onto the castle there. So this castle was the first one built in 1066 when the Normans invaded the UK. And the strategic positioning of this is because it's on the river. When the castle was built, and the locals, which was me and my Welsh countrymen, would lay siege to it, they were able to restock it from the river. They could pull the boats up and haul the provisions up from the river, so we couldn't starve them out so easily. But when they finally gave up and left and went home, we were left with another beautiful tourist attraction. So within about 20 miles of where I live, there's probably a dozen or so of these castles, but the one in the town here is a particularly good example. So yeah, I'm not a city boy. Rural Wales, very beautiful part of the world. If anyone ever makes their way to the UK, I'd ask you please think of putting the Wye Valley on your places to visit. It's quite a lovely area for sure. And thank you for the opportunity to do the ad.
Yeah. Oh no, thank you, Hugh. That's absolutely beautiful pictures you sent along. So very nice area. Definitely want to make that on my to-do list of places to go and visit. So very nice, very nice. So our topic today is IPTV, which is why we have you here from Mariner to talk about some of the peculiarities with it. I wanted to cover a couple of just quick topics in the news. One not related to IPTV, but the second one is. The first one is in North America. We always talk about squirrels chewing on coax cables and fiber optic cables. And, while they're cute, they can be a real pain in the butt. I was reading an article just yesterday about from Australia about another interesting animal, this time one with wings, and it's causing similar issues to what squirrels are. According to computerweekly.com, a group of vicious cockatoos with no known motive they're going around and they're eating coax cable. So so this is true. And according to Gisela Kaplan, a professor in animal behavior, is stumped on this issue because, as she said, it would have been an acquired taste because it's not their usual style, the style of the cockatoo. I laughed at that because an acquired taste. Do they get up in the morning and say, "I just love the taste of copper and dielectric in the morning" when they start chewing down? So Australia's having issues with cockatoos like we have issues with squirrels. I found that to be interesting. So next thing in the news I saw, according to Mashable, by the end of 2017, more than 22 million viewers age 18 and older are expected to have ditched their traditional cable bundles to date. That would be a 33% increase from the original 2016 figure, where they had anticipated only 15 million viewers would be cutting the cord, essentially. So that's 20. The new figure is 22 million by the end of 2017 versus the predicted 15 million. So it just shows a continued trend of cord cutting. So the number of pay TV viewers 55 and older will continue to rise over the next 4 years. So that basically 55 and over are going to continue to use the standard linear TV, sort of showing that demographic, where every other age for pay TV will continue to decline. Seeing the writing on the wall, several TV programmers, I think a lot of TV programmers, are launching their own pre-made IPTV-based streaming services. This leads us into IP video, something that Hugh has a little bit of background in. And there are some challenges with IP video or IP-based TV video, which is, I think, a very timely it's very timely to really look into this or to discuss this topic. A lot of cable operators are focusing on IPTV and how to deliver that over DOCSIS, how to manage it, what are the issues with it. I'm personally working with a number of operators that are doing that directly. So basically, I think this is a perfect segue, Hugh, to lead into this and start. How do we deal with this as an industry? What are some of the issues? And I think you have some talking points on this.
Okay. Yeah. Thanks, Brady. Yeah, I think the conversation really started when you look at where the cable industry is today, with the focus on DOCSIS 3.1, the DAA deployments, and the focus today, I would say, it seems to be on implementation and the stabilization of that underlying infrastructure. But I think it's an interesting observation that once that's done, the operational focus will shift to what I'd call the vagaries of IP delivery. Just because you have stable underlying plant in the fiber and the RF space, when you overlay IP services on that, there's a whole set of new issues which arise based around, as I say, the vagaries of the IP stack, and the fact that as a set of technologies, TCP/IP wasn't originally built by or constructed by Bill Joy to deliver the types of service demands that we're placing on it today. And so you have to be prepared that IP is not simply going to run smoothly over your network, however well it's conditioned. So, at the risk of being a heretic in the cable camp here, I'd say there's a lot that people in the cable industry can really draw on from the telco community, who've been through this exercise already. If you go back 20 years to when DSL was first deployed and IP video was deployed in telco environments, a lot of the challenges that face cable today were really addressed head on pretty early on and have been continuously addressed over the last 15 to 20 years. So if you use that as a model, that what happened then was when those first DSL enhanced broadband networks were rolled out, there were, as I say, a whole load of operational issues seen at the IP level. So that took a lot of people by surprise. And in fact, part of the origin of Mariner, the company I worked for, was that our founders were execs in a Canadian cable operator at that time, New Brunswick Telecom, which was one of the first to roll out IPTV in the late 1990s to consumers. And what they discovered was that operationally, when things were going well, it was brilliant. But as soon as something started to go wrong, actually working out what was happening in this end-to-end IP environment proved very difficult. What they realized at that time was that you probably needed a new class of operational tools just to give you the insight and the visibility of what was happening in that environment. And so anticipating that there'd be a need for that type of tooling, Mariner was founded partly with that goal in mind. Now, it's been a long evolution since then, 15 to 20 years, technology has evolved, and we maybe talk a little bit about that. But the fact remains that telcos today still spend a lot of time addressing issues that arise with the IP delivery of their services over very, very well configured and conditioned networks. But the uncertainty of demand pressure, the sort of multiplication of services, the amount of content, the places it's coming from, there's an explosion in the technology in the environment, which means that these stresses and strains are a part of life in that environment. And so I think perhaps the interesting lesson for people in the cable industry as they move forward, particularly with DOCSIS 3.1, which is a game changer because of the size of the IP pipe you're now able to offer, and the expectation that more of the service portfolio, the high quality services, may be delivered over IP, then that's going to bring the cable industry head on in front of these same issues that affect IP delivery in other network types.
So when you're talking about IP delivery, I mean, is all video, is all over the top video IP delivery, or do you break it into, is there different types of IPTV? And so that's, I think, something that we need to understand as listeners, because like Netflix, we think is IPTV, but then there's also IPTV that cable operators can, I think there's different types of IPTV, right?
Yeah, I think originally IPTV was very well defined in that there was a class of technologies before adaptive bitrate video came along. We used constant bitrate video using UDP, an unreliable transport protocol, to transport video into homes. And this was the first generation of what were called IPTV services from telcos. So that generation of services delivered in a what looks like a very conventional pay TV infrastructure with video servers, your application servers, and then at the other end set-top boxes connected to TVs. That used the available set of technologies at that time to stream video. We didn't use reliable transport because the time taken, there were lots of issues over timings, and acknowledging every packet that was sent was too much of a challenge. So we used unreliable video, and so packet loss with those technologies, what I'd call traditional IPTV, packet loss was actually the biggest issue. That you'd have network equipment knowing that an unreliable transport was being used, would arbitrarily discard packets here, they're not seeing it as network issues. They're allowed to do that if pressure comes on. The resulting impact on consumers was pixelization or freezing of the picture if you lost enough of the data coming across. So to deal with that, there were technologies that were developed. Some of them were built into the IPTV middleware solutions themselves. Others, in fact, the one from Cisco called VQE was a packet repair technology, which said if you realize at the STB you're missing some of your data, you can send a quick request to have it resent and hopefully fill that hole in the buffer in the set-top before it's impacted on screen. So these packet repair technologies around video repair became popular as a way of overcoming low-level pixelation, low-level loss. Now, as I say, I'd call that traditional IPTV, and certainly if you talk to people in the telco community, they would think of IPTV by and large as based around those earlier technologies. ABR was a bit of a game changer, and if adaptive bitrate had been around 10 years earlier than it was, we probably would have used that from the get-go, because the idea that you have a reliable transport layer, so you're not getting such arbitrary sort of small-scale packet loss causing pixelation, that has real benefits, as does the fact that with the different profiles, so the availability of the video at different bit rates, mean that these pressures that come and go in a network where your demand is increasing and reducing and increasing, the ABR technologies allow you to deal elegantly with that by saying, from a client's point of view, I'm losing bit rate, my buffer is starting to get exhausted, I'll lower the bit rate in order to top up while I'm getting lower speed, and when things recover, I can move back to higher bit rate. So it's a very elegant set of technologies to deal with, firstly, the reliability, and also dealing with the vagaries of demand and congestion that's happening in the network. Now, wherever ABR is used, you tend to think of that as a newer form of IP video, which is typified, as you say, by people like Netflix, but also by TV Everywhere type services. So anything that that comes under that ABR umbrella would tend to be regarded not as traditional IPTV by people who were involved with those early technologies. There's almost a technology split between the two.
And just so I understand, when you're talking about ABR, adaptive bitrate, I mean, we see this all the time with like YouTube or Netflix, where if something happens in a network, we may be seeing like a really high def signal, but then suddenly it drops down to lower definition and the picture gets a little bit fuzzy, and then it goes to a higher bit rate, and now the picture gets really clear. That's basically what you're saying ABR is, right? That's
right. And there are a couple of features of ABR which are elegant but very unappealing to consumers, and they extend from slowness in stream initiation. So occasionally you see delays in getting content up and running, and consumers don't have a lot of patience if they have to wait too long for their content to arrive. They generally click away, they'll go and do something else. The one that is the most damaging of all is rebuffering. So although you don't have a failure of the stream, you see your little spinning icon telling you that the system's thinking, well, it's basically recharging its buffers in order to carry on playing. That's the single most damaging thing in an ABR environment. I think there's plenty of research out there that says, would indicate the first time you have a rebuffering event, the first time a consumer sees that for a particular stream, you probably lose close to 20% of the viewers, because people say, if it's happened once, it's likely to happen again. Life's too short, I'm going to move on and do something else. If you have a second or a third rebuffering event, your rate of abandonment goes through the roof and can reach 60–70% quite easily. So the whole, if the goal of video engagement is to keep people watching your content, so that they're watching your advertisements, they're paying for your services, they're having a good experience through you, the idea of people abandoning their viewing experience and being dissatisfied as a result of that is actually hugely damaging. And even with ABR, whereas with the older technologies, we used to get pixelation, which was frustrating, picture breakout, picture freeze. Now the thing will keep going if you allow it, but people's expectation of a video experience is such that they're not prepared to tolerate that kind of disruption for long, and that's hugely damaging. I think the other point about this, which is an evolutionary trend, is that the sort of the difference you highlighted early on there, your perception of something like YouTube years ago was it was something of a novelty from a video point of view, and you would accept as a consumer that quality of experience did not match what you expected to see on your big screen TV in your lounge room. So there was, in consumer perception, a difference between low-grade, acceptably low-grade video experience that they might have as a novelty value or on a device where they didn't really expect the video to be great, and what you had in your lounge room where you really expected quality to meet the expectations which has been set by pay TV over many years. And what's happened over time is those two worlds have converged. They've converged technically because these days, you know, apart from legacy quote unquote IPTV services, pretty much everything is being done using adaptive bitrate. But the expectation of video delivered to other devices or delivered even to your main TV through you know, a box that you plug in, a streaming box that you plug in, the expectation of consumers is increasing all the time. So now consumers just don't accept that you know, a poor picture quality is acceptable wherever it might be. So you've got an evolution of technology on the one side towards adaptive bitrate, and you've got an evolution of consumer expectations on the other. And I personally find it very difficult to speak of anything we do today as IPTV. I just think of it as IP video, where there's an expectation of quality, which we should really be striving for across the board, regardless of device, regardless of screen size. The only way to ensure you're catering for your consumers' needs is to actually aim for a ubiquitous level of service really across all devices. And I just call that IP video today rather than IPTV.
Okay. So John, we have, you know, so we were talking about variable bitrate, and a lot of this stuff is going across our DOCSIS networks. And it, you know, the bitrate may go down, the bitrate may go up, having rebuffering issues. Is there anything that the CMTS sees? Like, does the CMTS treat IP video traffic any differently from other types of traffic? Is there anything that the CMTS can do or be optimized from the standpoint of improving IP video traffic? And what are operators doing with this type of traffic today, from your experience?
So, you know, I always have an opinion.
That's why I asked.
This is probably the most quiet I have been in 20 minutes in one of our Google Hangouts. So I've been hanging back, listening the whole time. And I have about 4 or 5 points. One, adaptive bitrate. So you have variable bitrate, you have adaptive bitrate. Adaptive bitrate is TCP based. So one of the major things I think about on a capacity planning side is I might be doing downstream video, but it's requiring upstream acknowledgements. So just throwing more downstream speed at something to get a bigger downstream pipe doesn't do me any good if the upstream pipe is congested with acknowledgements. So I have to make sure that my upstream is, you know, just as clean as, say, my downstream. Or if I start increasing my downstream pipe, my upstream pipe has to increase as well. Now, what I found is a lot of modems that are doing upstream bonding, downstream bonding, the ACKs are concatenated. We have modems by default will have what is it called? ACK suppression, where say 4 acknowledgements come in, the cable modem might say, hey, there's 4 acknowledgements in my buffer. Let's drop the first 3 and send the 4th. So instead of requiring, say, 1 ACK for every 2 downstream frames, I might be getting better TCP windowing, if you will. So I won't require so much upstream speed to support downstream speed. But when I start looking at adaptive bitrate, most of the services are 5, 7 megabits per second. They're not 100 megabits per second. They're not 1 gig. All these video streams, and that's another key point, is the reason why it's adaptive bitrate is I might be watching on my phone, then I'm watching on a tablet, then I'm watching on my 4K TV. So there's different bit rates needed for those different types of viewing devices. So it's changing depending on the speed I have in my house and everything else. But I have maybe 5 different screens going on at the same time in my house. But each one is only requiring maybe 5, 3, 7 megabits per second. I found that each of these service flows don't really get the advantage of ACK suppression because they're really not that fast. If I was doing 100 meg down, a TCP 100 meg down, normally it'd be about 2 meg up just for ACKs, but with ACK suppression, it might be 700 kilobit per second. But if I'm only doing 10 meg down, I don't really see ACK suppression really coming into play very much. So I'm still about a 1:50 ratio on my downstream to upstream. So with the multiple flows, I could have considerable upstream traffic that I wasn't aware of or wasn't planning for. So going to DOCSIS 3.1 is great. Throwing a bigger pipe at it is great, but I have to make sure my upstream is ready for it. 5 to 42 megahertz spectrum allocation is pretty tough. To get more than say 4 ATDMA upstream to get 108 meg aggregate pipe on the upstream. So that's capacity planning considerations. The other one was the adaptive bit rate. More speed does not necessarily equate to better QoE, quality of experience. And I'm sure, Hugh, you can talk about that. It's like quality of experience. Now you're talking about jitter latency. On the CMTS side, I have a feeling, and I haven't really tested this out that well yet. Could I exploit downstream power boost to allow some of these ABR flows to load up faster for maybe 5-6 seconds as they buffer in? But will that power boost then screw up my ABR? Meaning, if the TCP windowing is setting up, the adaptive bit rate is readjusting, how quickly does it readjust? How long does my power boost actually last? And you understand power boost, right? Like if I'm paying for 100 megabit per second, the CMTS provider or the cable service provider might have a power boost to 150 or 200 megabits per second for 8 seconds. Will that make my pipe appear bigger, which allows my ABR to load faster and buffer faster? But then what happens when the power boost comes down? Does the ABR automatically readjust and have to? And it would. It's adaptive, right? So there's some questions there about, could power boost be a good way of exploiting ABR or vice versa? I don't know.
Improving the quality of experience for the end user, ultimately, I think is
at least for that first load up, right? Because you might be doubling the speed just for say 8 seconds. And maybe that's enough to load up the buffer, because really adaptive bitrate and over-the-top video, you're loading a file. You're sort of loading a file. You're loading it up, and then it's buffering, and then you start watching it, and it's still loading as you're watching it.
Yeah. So I think this view takes us into the aspects of IPTV, which, I mean, for me as someone who does consume some of the IPTV services over the top that are available, sometimes, quite frankly, they really suck. and I can't figure out, well, is this because of my modem service? Is this because of my Wi-Fi service? Or is this just because of the provider not doing a good job? So, and I can't tell. I try to troubleshoot it, but still I'm having buffering problems, or it's just slowing down really bad. And even still, I have really high speed data service at my home. Yeah.
So
Wi-Fi is the point. The Wi-Fi side of it is a good point.
I've got good Wi-Fi too. At least I think I do.
Think about it. Everyone is pretty much, you might have one device that's wired and everything else is Wi-Fi.
Yeah. So yeah, Hugh, help us through this.
To John's first point on the power boost, I think there could be a case there, because there's a parallel in the telco space, which is this initial buffer fill and people's tolerance for waiting for things to happen, waiting for a stream to start. That was overcome by some bursting technologies, so fast fill technologies, if you like. That is something that's been done in the telecom space, and if the way of achieving that through the CMTS is with this power boost function, then that could certainly be something worth exploring. You do have, more generally, I think that solves one aspect of the problem, but you have a more general issue that you just described there, Brady, which is that because this technology back in the the path between the content being served out and the consumer, there's so much variation that can happen in that if you address a particular pressure point, that's a good contribution, but you really do have uncertainty end to end in terms of a proliferation of technology here, where your content, are you acquiring, transcoding, packaging, as that's being distributed through the CDN? How is the CDN performing? Are there pressures coming on there? If you've got multiple CDNs as service provider, how do they perform relative to one another? What's happening as this flows through the IP portion of your network, what congestion do you have there? Could that be improved by alternative routing or sourcing or switching customers to different CDN nodes? And then when you get to the home, the whole set of vagaries inside the home around, you know, what is the connection mode? You just discussed it. You know, Wi-Fi today is widely reported to be responsible for, let's say, over 50% of trouble calls coming into service providers. So a piece of the delivery environment that in essence you'd like to say, well, that's the consumer's responsibility in many cases, but that's absolutely not how the consumer sees it. They expect the services to be delivered to all devices. And if you're getting, you've got a bit of a double whammy there of services being delivered or not, you know, services not being delivered well over the Wi-Fi interfaces, but your incremental revenue as a service provider for offering those add-on services, it's sort of become table stakes to offer TV everywhere, to offer to other devices, to offer to wireless set-top boxes. But you're not getting a lot of additional revenue for that. But the complexity means your operational costs associated with supporting those devices are actually very high. And it sort of leads us towards a discussion that we'll maybe come to in a little bit about the benefits of good operational tooling, service assurance tooling around what's happening. Because to come back to your statement, Brady, about your own experience, the only real way to get quickly to root cause in these environments is to be collecting instrumentation from all points and using that not in a set of siloed individual operational tools which look at what's the CDN doing, what's the network doing, what's happening in the home, what's the application doing, but actually pulling that data together so you can compare and contrast and correlate in different dimensions, as we call them. So some of those dimensions might be topologically based. If you have you know, at least a representation of some layers within your network, you can actually triangulate in order to see from the edge devices what's the patterning of issues that's occurring at the edge, and where does that suggest might be the root cause for this. So even if there's a switch somewhere which is not itself reporting alarms or reporting issues, it could be that something on the video flows through that switch. There are delays which are not network alarmable, but are actually causing disruption to service from an end consumer point of view. So you have that kind of triangulation. You could do the same thing to your CDN infrastructure to say, is this a particular CDN node, or is it a particular piece of content which is where the common issues that people are having are shared by some component of that type? Or even within the home, what we see with you know, with some of our customers is it may be that there's a new version of a sports app on a particular device, or a particular OS version on a particular device. That app is actually having issues because you can't exhaustively test all the combinations of apps and content and devices and OS versions that are out there. You do a reasonable testing, you think you've done your due diligence. When you actually deploy into the field, you might find, and I'm not going to pick on any specific device, a particular device running this version of the OS, this app does not appear to work successfully there. In fact, everybody who's using that device with that OS is having problems. As a service provider, if you have that level of visibility, you have instrumentation about what devices are being used, what the environment on that device is, how it's connected within the home, how it's connected back into your network, and how it interacts with your content and with your applications. You can, through a process of elimination, say, I know it's not this, I know it's not that, because there are lots of people having good service, but what looks to be the common denominator here for the problem I'm seeing is this aspect, a piece of network congestion somewhere affecting a geographic area, or a particular device having a problem with the newest version of the app. The only way to get to the level of visibility you've discussed aspiring to, Brady, is really to try and build that comprehensive view of the service environment.
Okay. Are you able to give us like an example of maybe something that in your experience you've seen that will cause the types of problems where, you know, maybe there's a lot of buffering, or there's just really poor customer experience with IP video?
The ones that are they're a high profile events. So even recently with ABR, with we're into this era now where very high profile, quite often pay-per-view events. So a boxing match or a big soccer game. People will subscribe to that event, and there have been several recorded issues of the streaming services failing. In several of them that we've had visibility of, people automatically assume something has happened with the streaming servers, that something has failed at the streaming servers because the issues are so widespread. In at least 3 issues that I'm aware of, it was actually the authentication servers which were completely log jammed. So many people trying to get authenticated to watch the content, in the few minutes running up to the start of the streaming, they went into long queues to get authenticated. And while they're waiting to be authenticated, the streams are not appearing for them. So they're reporting this as I bought this content, I'm in there, but I'm just not seeing the stream. The operational staff, in a firefighting situation, start looking at, well, something seems to be wrong with the streaming. The customers are not receiving the streams. After the event, when things had calmed down a bit, in several cases they looked and they found actually it was customers waiting to be authenticated to access the stream. So those companies that have experienced this have said, either we need to allocate more capacity from the get-go, or if this is a virtualized environment, we can just spin up more instances to authenticate more people. We need to be prepared for those pressure points. So those are examples where there have been repeated of those over I would say a 12-month period, where different operators have seen exactly the same phenomenon associated with authentication servers, just because they didn't anticipate the high demand that would happen in the immediate run up to the event. But the way it manifested itself didn't immediately lead people to think this is what the problem is. It was only after the event that they were able to troubleshoot. So that's one. There are simple things like we do occasionally see misassignment of IP. So you get a duplicate IP address. I think the worst case we ever saw with that, there were a couple of 100,000 people affected. So an IP address on a port somewhere was misassigned, someone overriding the system, doing something manually. Suddenly a vast number of people was cut off from service because the routing tables just stopped sending stuff into their part of the network. That was quite a big one. But then there are more subtle ongoing things. So we see issues such as soon as you start gathering information from the edge and start triangulating it to see what people have in common, where they're having subtle issues, you find configuration issues on switches where the impact they're having is very subtle. It's causing only at times of peak load. So these are transient issues that come and go. But when the pressure comes on, they're not able to service people. There's slowdown, delays are introduced, people start.
May have lost Luke.
Sorry.
Oh, there you are, Hugh. You came back.
Okay. I don't know.
You broke
how
up there.
Lost me for. What I was just saying is you do have these situations where sorry, I lost my thread then because my screen went blank as well, and I thought I'd lost you. You have a situation where if you can identify which of your network nodes are actually the focal point for a lot of this sort of subtle damage you're getting at the edge, you can say, well, go and look at that node, see what's happening at that node. There's something going on there which is causing damage. And we in one instance, I think we saw that 10% of trouble calls originated from a pool of people who were being impacted by issues on a very small number of network nodes, where there were configuration issues, where when pressure came on, service degraded to those subtended communities. But nothing in the network itself was flagging that up as an issue. So there are subtle issues, and the downside of this is it has a hugely damaging effect on customer satisfaction, and at a time when everybody's focus is on CSAT and customer retention as a, generally even an exec level remuneration impact, how do our customers feel about our service? That's what we're going to measure ourselves on. All these subtle issues which impact customers actually have a very negative effect, particularly when people increasingly have an option of going elsewhere. They're not locked in for the long term. They will vote with their feet and say, I'm going to try something different, even on the basis of a single bad experience. So the issues, some of them are major, you know, they even make it into the public domain. You read about them in the media because they're so big. The impact of a failure is so big. Others are actually about subtle, ongoing ways in terms of trying to keep hold of your consumers. Another good example is, you know, what are people's aspirations for installation and repair success rates? So first time right on an installation or repair. There are service providers out there who target 95% plus. Now, I think for many operators in our industry, that's an unimaginably high figure that, you know, within the first 30 days, you're not having a call from those customers because they were installed well from the get-go and there's no follow-up. That seems to be the exception rather than the rule, where there's still a lot of after the event, you know, issues, things not installed properly, things not running as smoothly as you'd hope from the get-go. Wi-Fi is a big one in that, and I did want to talk specifically about that because you both raised it. One of the tooling areas where you really have to take out the load on your call center is around Wi-Fi in home. So there are lots of free tools that people can use in their home to check out their Wi-Fi, see if they've got, you know, channel usage overlap, co-channel interference, or even worse, adjacent channel interference in their Wi-Fi configuration with something their neighbors are doing. Maybe change the configuration of their Wi-Fi to avoid, to find a clean area. But Wi-Fi situations change. You know, your neighbor may reconfigure their equipment without you knowing about it, that has a negative impact on you. So what you really want from a service assurance point of view there is part of the ongoing monitoring and collection of instrumentation, just constantly to look, is the Wi-Fi environment in my home changing? So not only do I say, this is the best place to put your access point, you will now get good service in all these rooms, but if you're in the far bedroom, you actually need a repeater in order to get to that point of your house. Even after it's all set up and working properly, you need to be vigilant about watching what's going on, and ideally do that automatically and give the information back to the consumer if you spot something that's changed that's likely to impact their service. So Wi-Fi, I think, is a you know, a huge issue area across the industry. It's not limited to cable by any means. Any broadband service provider running services over Wi-Fi in the home is having the same challenges. And the answer is not really just to provide better tooling so that when someone calls you, you can solve the problem. You really have to eliminate that at source by allowing people to help themselves, or automating the reconfiguration in order to overcome the issue. But Wi-Fi is possibly the biggest ubiquitous single channel challenge out there at the moment.
Yeah, and I think we're seeing that throughout not just IP video, but all services. Customers are even doing like speed tests across their Wi-Fi and saying, well, you know, you're not meeting our service expectations, even across the DOCSIS network. So John, do you have any questions or input before I ask you another question that I have? Or can I go ahead with my question? It looks like you may have your mouth full there.
One more thing I was going to bring up, and that was, I thought it was kind of ironic that I think it was Comcast was saying, instead of doing analog reclamation, we're now looking at digital reclamation, meaning let's get rid of our, you know, digital channels MPEG-2 and go to IP video, which is MPEG-4. So you get better compression. But it seems like every time we figure out how to do better compression, we just come out with higher resolution anyway. So we go from, you know, standard definition TV to high definition TV to 3D that seemed to peter out. 3D TVs, I don't see nothing with that. But we have 4K TV, and what's coming up next? 8K or 16K TV?
8K coming up yet.
Yeah, so I mean, every time we find better compression, we just come up with more resolution. So we still end up with the same amount of content, say in a 6 megahertz pipe, or in Europe's case, 8 megahertz pipe, and when we go DOCSIS 3.1, there is no such thing as an RF channel, you know, for that matter. But you get my point is we seem to try to squeeze more than 10 pounds of potatoes in a 5-pound bag. So it's no matter what we do to get it more efficient, we'll always figure out a way to fill the pipe up. More content or higher resolution content. So I thought it was kind of interesting, just going to IP or MPEG-4, that could be a way to push people to change their set-top boxes from the old analog set-top boxes to the new IP set-top boxes. And not just for that capability, but also there's other functionality in an IP set-top box that's better suited than the old legacy set-top boxes.
Yeah, so we keep getting more efficient. So I think my question, John, back to you was more on the line of the CCAP, Converged Cable Access Platform, right? So on the CCAP platform, the concept there is we would put both data and video or IP video over CCAP. Are we seeing the industry do that?
That I don't know. I don't think I have enough insight into that side of it. I do a lot of capacity planning on the DOCSIS side, and video is. We have a couple customers doing VDOC. We call it video over DOCSIS, with multicast and things of that nature. But it's not a big push, I guess. But it's getting more to the limelight now, and I think you're right. It's kind of like get on, what's the saying? Get on the bus or get left behind, or get on the wagon or get left behind. I said this about 20 years ago. We cannot afford the cable industry to be a dumb pipe. If you're just a dumb pipe offering speed, someone else is going to come along and offer a service, and we're going to get bypassed. So back in the day when cable customers or cable providers had pay-per-view, that was great and all, but now I can just bypass that and just go right to Netflix. So it's in our best interest to create an agreement with these over-the-top providers, which is some MSOs have done, right? They're offering Netflix on their system with a quality of experience or quality of service that's a little bit guaranteed, other than just saying, here's a dumb pipe.
Yeah, and there's been a number of announcements where operators are doing that partnership with over-the-top providers. And I think one of the things I'm curious about is whether or not those partnerships can offer that guaranteed quality of service that you're suggesting, John. And then I'm curious also, Hugh, if you've seen, do those relationships improve the quality of experience for the end user? Are there less problems? And is that the way that the industry should look at going?
Well, okay, if I can go first, John. So the answer is yes. There are clearly regulatory constraints over, to what extent you can act in favor of certain content over others. You're not allowed to create a fast lane per se. But one of the benefits I've always felt that network owner operators have over the pure over-the-top plays, and the opportunity they have to strike these relationships, is that if let's say you're Netflix and you're offering over someone's network with whom you have no relationship, you have the challenge that all you can see is what's happening at the time you are generating the streams and what's happening at the device where they're being consumed. You have no visibility of anything that's going on in between at all. So if there are issues, you can attempt to second guess where those issues might be, maybe start streaming from a different node in order to take a different path to the consumer, but you really don't have that visibility. If you are a network owner operator, a huge advantage you have if you have tooling that gives you visibility of your end-to-end network environment is that you can intervene, particularly when you see degradations rather than failures. So don't wait until something's hit the proverbial before you intervene. You actually look for those signs that things are starting to deteriorate, and then you intervene in order to spin up more resources, change your routing tables, do whatever you need to do, spin up more capacity on the stream generation in order to cater for the demand, and you reverse the degradation trend. Now, that's an offer that anybody who owns their network can make to people who want to offer higher quality over that network environment, is to say, by doing a deal with us, you actually buy into the use of our tooling, which is going to help deliver a better quality to end consumers. So I think there is something positive that network owner operators have that's a very good defense against the pure over-the-top players, if you can structure it in a way that makes commercial sense to you. And that's clearly the $64,000 question. What do the economics of this look like in terms of cannibalization of your existing business versus what you can get as a quid pro quo from doing a deal with the new provider? But there are certainly things that are in the service provider's armory that they can, the network owner's armory, that they can bring to the table and use as a negotiating chip to try and improve ambient quality for consumers. And particularly, of course, where it's a bundled resell of the over-the-top service, as it is with some service providers now in their relationship with Netflix, it's in everybody's vested interest to try and deliver those services in the best quality possible.
Yeah, so one of the things that I've seen, particularly smaller operators doing, and I know the large operators are doing this, is they're getting caching servers. And depending on your size, even small operators will get almost free caching servers. So that from some of these over-the-top players, and they look at how much traffic is going to the smaller operators, and either for a certain cost or no cost at all, cable operators can get a caching server. They can put this caching server in their head end. And then what happens is the very popular content from the overtop providers gets locally cached on that caching server. And so this can help with costs for the cable operator, because that they're not pulling the streams continuously from, let's say it's Netflix, for example, and House of Cards, whatever the popular Netflix show is that everyone's watching regularly, it just gets pulled one time from Netflix. It's stored locally on the cable operator's caching server. And then every time a subscriber pulls the latest episodes of House of Cards from that cable operator, instead of it coming directly from Netflix, it's now being served off the caching server that is located in a cable operator's head end. And so from my perspective, we are reducing the number of servers, the number of points of failures that over-the-top episode has to go through in order before it gets delivered to the cable modem and then into the subscriber's network. So these are things that I see that, as you said, Hugh, we can't provide a fast lane for the IP video because that, kind of goes against regulations and stuff like that. But we can do things as an industry that improves. We can work with the vendors. We can put these caching servers in place, whether or not we have to pay for them, or we can get them because Netflix knows that this is going to help the end customer. It's going to help the service performance, but it's also going to help the cable operator because, again, cable operators are paying for that backhaul and the amount of traffic that's going over that backhaul. So if we can reduce that traffic, we reduce the points of failure, and in the end, we're helping the quality of service for the subscriber. So I mean, these seem like things that help from my perspective. I don't know, Hugh, if you've done testing, or John, if you've seen testing or indications that these actually do help in the long run.
Well, I think I'll pass back to John, but it's sort of just an observation there, because it touches on something you said a moment ago, John, about where's how do you ensure that there's value built into the operator's network environment, and these are things that they can do. They can proactively do things that are for the benefit of consumers wherever the content is coming from, and that's, you're sort of moving up the value pipe in terms of making services available which might allow third parties to deliver. If you don't have a commercial relationship where you're bundling content, maybe it's some other commercial relationship you have with them, but you can add value in because you have the ownership of the network. It does put you in a good position, if you're thoughtful about it, to how you make sure you're not, your role is not continuously devolved and evolved. You actively participate in trying to ensure that whoever's services they are, they're making their way to consumers, and you look for some quid pro quo for doing that.
I would have a couple comments on like the caching servers. Memory is always getting smaller and cheaper, so it becomes more economical to do that. The other one would be, I think you talked about earlier, DAA, distributed access architectures. Once we get rid of our analog fiber and go digital and remote PHY and distributed access architecture, DAA, we can manipulate our capacity almost instantaneously. We have the fiber optic nodes on a Metro Ethernet ring. We can allocate spectrum a lot more efficiently. We see that one node is off a college town and it happens to be a weekend, everyone's watching the World Cup or whatever online. Maybe we can throw more capacity at that just for the weekend. Maybe we can throw more capacity for the week or the month. So we can manipulate the capacity and move it around and be a little bit more economical as well. Instead of allocating spectrum and capacity and licensing for RF channels, if you will, on a cookie cutter design, we can manipulate that capacity wherever we need it and wherever we feel we need it. So as you said, we could give more capacity, but we still have to guarantee that just throwing more speed at something doesn't guarantee quality of experience, right? We still have to look at maybe deep packet inspection so we know what's going on, and then how to do better quality of experience for latency and jitter sensitive services. That's just a couple of key points.
No, I think that's really good. I mean, it's very important for everyone to understand that the CMTS is another router, or the CCAP is another router in the chain for the IP video traffic to get to the end subscriber. And especially if that becomes congested or any impairments that happen, just looking at it from an IP standpoint, we see many times CMTSs and CCAP devices start running at 80, 90% utilization during peak traffic times. And that is definitely going to cause problems for IP-based traffic. So to your point, John, being able to identify that and increase utilization or reduce utilization on the CMTS or CCAP, like when there's going to be a big game on a weekend in a college town and everyone's streaming it, that's fantastic to be able to identify that as a problem or a weak link and be able to mitigate it and help the subscriber.
And the one step past that would be eventually you get rid of the CMTS or CCAP box altogether, and you have virtual or cloud CMTS, right? So you really have a data bank of servers.
Yeah, where you could spool up another server, add more traffic to it, and capacity as necessary.
Yep.
So, thoughts on that, Hugh?
Yeah, I think flexibility around capacity and certainly the DAA, whether it's remote PHY Mac, depending on how much of the intelligence you're pushing out towards the edge, just does give you that flexibility. So I think that these technologies work in harness as you've just been speculating there. I did want to come back to the DOCSIS 3.1 point in particular, because certainly from arm's length, I'm not steeped in the cable industry per se, but it does seem to be a real game changer from my point of view in terms of the use of IP. So you were talking a few minutes ago about what content will go where. I still think there's the bulk of cable providers are looking at continuing to offer their digital broadcast channels the way they have been and using IP capacity for other services. But 3.1, whereas the 3.0, the channel bonding gave you a certain increased capacity in the IP pipe, what happens with 3.1 is so dramatic in terms of opening up that bandwidth. Suddenly you can start looking at doing much more dramatic things with the way you transport the payload and the balance between what you do using traditional digital cable technology versus putting things into the IP domain. You've suddenly got a lot more flexibility over how you do that. It's helped by pushing the in these distributed architectures, putting more of the intelligence out to the edge, which gives you some scalability and some space saving at the head end. But what I don't see today is a real commitment to dive in both feet into saying we're just going to shove everything over IP. I think there's a natural caution about, you know, well, even though this capability is there, how do we move down this road of understanding what that means in practice, and you know, the IP-ification, if you like, of the outer edges of the cable network, I think is going to be a little bit longer coming. That's certainly my experience from talking to people. I don't know if you have a different view, if you think there are people who are really, you know, going to dive into doing a lot of their high-profile content, put it into these IP pipes when they're available. My impression is there's going to be a bit more of a steady as she goes. So you've provisioned with DOCSIS 3.1 the capability and the ability to explore and expand what you're doing in IP, but that will actually be an evolutionary process rather than something that happens very suddenly.
Yeah. I mean, definitely 3.1 gives us a lot more capacity, but we always seem to manage to fill up that capacity. Yeah. If you build it, they will come.
Yeah.
What I always felt with DOCSIS 3.1 is not just the capacity, the fact that it's so much more resilient than we thought. And that was part of my speech for Expo this year, was the fact that you're not relegated to the weakest link, meaning if one customer can only do 256 QAM, not all customers on the service group are going to drop. So you can do per modem modulation, which is awesome. But I think it's almost like, I'm thinking out loud here, we should take this a step further. And I think I told you this before, Brady. It's like, when a customer has poor RF quality, should we also have like packet cable multimedia give them a different quality of service? Because if he's still trying to do high definition TV or IPTV or higher speeds, he's doing a lower modulation, so he's taking up more time on the wire. I should say, you know what, his RF is subpar, so I should also give him a subpar quality of service. I should throw him down to 50. No, I mean, I should say, you have this other guy that's more efficient can get his 100 megabit per second in 1 second, but it's going to take you 2 seconds because your modulation is half the speed. So maybe I should actually drop your quality of service to 50 megabits per second until we fix your problem. That way you're not eating up all the pipe, because you're still sharing a pipe with everybody else.
Right. No, I understand what you're saying.
You know, and I know, I don't know how that would fly, but you get my idea.
Yep, absolutely. So, guys, we've come to the top of the hour again. Any final comments before I wrap up this episode?
I'd just like to say thank you, Brady, for the opportunity. Good to meet you, John, and you know, I've enjoyed it, and you know, I do think, you know, just having spent most of my working life in IP, it is pretty exciting seeing what the possibilities are now as cable moves further down this road. So I'm just looking forward to see how this thing plays out over time. It's a very exciting time to be in and around the industry for sure. So thanks for the opportunity, and looking forward to chatting again.
Yeah, it was a pleasure. And if I ever make it out to your neck of the woods, I'm gonna be looking you up.
Yeah, definitely going to head to that the Welsh Valley. So, Mr. Downey, Mr. Price Stevens, thank you for your time today. This was a great episode. We do our best to bring our audience great technical content every month. You can watch us live or catch our events on recorded episodes on YouTube or on the volpefirm.com/events channel, or download our audio-only version with your favorite podcaster. If you enjoyed this webcast, please do hit subscribe so that you will never miss an episode. Thank you, everyone, for being here, and we'll see you next month. So, bye, all.
See ya.